The MRC-NIHR Phenome Centre was created as part of an initiative to reutilise some of the instrumentation that was deployed for the Olympic 2012 drug testing. That facility was originally at Glaxo in Harlow, and it was of course designed for highly targeted assays for substances of abuse. We decided that this instrumentation could be used in a very interesting way post-Olympic Games, which is to have a much broader analytical capacity to look at metabolites that are part of us, the metabolites that come from our gut microbes, metabolites, the drugs that we take, metabolites from the environment, environmental chemicals. So a whole range of different molecules that flux through our bodies, which impact strongly on our health and the likelihood of us getting diseases. There are two fundamental technologies that allow us to do this. One is nuclear magnetic resonance spectroscopy, and the other is mass spectrometry. And these technologies are the ones of choice because they could cover hundreds or thousands of metabolites in a single analytical run on a particular sample.
For the Phenome Centre, we have three state-of-the-art magnets, all of them equipped with sample jet systems. The idea is for high throughput analysis of urine and plasma or serum samples. With the Phenome Centre, we're running one-dimensional and two-dimensional NMR data. One-dimensional is very handy for pattern recognition studies, and two-dimensional data we're generally using to assign peaks in the complex mixtures we're working with.
The mass spectrometers, it depends on what you do on them. You can do so-called exploratory analysis, where you're looking for a whole range of different things without having decided exactly what you're looking for. And that's actually quite important because, believe it or not, there's most of the things in biochemistry we actually don't know. So we often don't know what we're looking for when we're looking for human diseases. We want to explore and find new biomarkers, molecules that indicate disease in a discovery process. When we've discovered new molecules or discovered old molecules that are informing us about biology in new ways, then we want to do some so-called targeted analysis. And that involves a slightly different sort of mass spectrometer, so-called triple quadrupole mass spectrometer, where we use isotope dilution techniques.
One of the greatest challenges of the Phenome Centre is going to be taking this enormous amount of data, up to 2 gigabytes per assay, of which we might be running 5 or 6 assays a sample, and integrating it into a coherent data set. One of the major challenges will be extracting features, so identified metabolites or molecules from the general data sets, and then inferring concentration or relative abundances. The Phenome Centre is lucky to have the capability to run both NMR spectroscopy and mass spectrometry, and the two platforms provide very complementary information, both in terms of the classes of compounds that the particular platforms are able to give us quantifications for, but also in terms of allowing us to use advanced 2D NMRs for metabolite identification, or leveraging the much greater sensitivity of the mass spectrometry.
So the combination of NMR with mass spec allows you to do very detailed structure elucidation to say exactly what molecules are, and the way the technologies work allows you to look at lots and lots of different molecules at the same time, so be very, very informative about chemistry of the sample and the quantities of the molecules that are present. We're actually in phase 1 and we expect it to expand. The phase 1 has 16 state-of-the-art mass spectrometers and 3 high-field NMR spectrometers. The high-field NMR spectrometers on their own can handle 25,000 samples a year. The thing that's unusual about our centre is the amount of parallelization of the technology. So for instance, we've got 10 identical quadrupole time-of-flight mass spectrometers for exploration, and we have 6 identical triple quadrupole mass spectrometers for targeted analysis. There are very few labs anywhere in the world that has this parallelization, which means you can cope with very large numbers of samples fluxing through your system at any one time.